I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for solving systems by substituting. Remember that in a system of equations, the solution is the point of intersection, which is where the x and the y values are equal in both equations. So as a result, we can use substitution for solving by replacing a variable in one equation with the same variable in the other equation. In other words, we're assuming that y equals y and x equals x. That is for both equations. So I'm going to show you what this looks like. So in our first example, notice that we have both equations already solved for y. And so what I'm going to do is I'm going to replace this 2x with this y. Because again, according to this equation, y equals 2x. So that means if we're going to solve this, then this y also needs to equal 2x. So 2x equals x plus 5, and I'm just going to use algebra to solve, minus x equals 5. So that's the x value of my solution, 5. Now I need the y value of my solution. Well, in order to find the y value of my solution, I just plug in 5 back into my original equation, y equals 2x. Y equals 2 times 5, which is y equals 10. So the solution is 5, 10. So if I were to graph these on the coordinate plane, this is the point where those two lines would intersect. Now here, only one equation is solved for y. And so the equation that is solved for a variable already is going to be what I'm going to use to substitute. So I'm going to substitute the x minus 4 for y in the other equation. So this is going to become x minus 4. So 2x plus, and I'm going to go ahead and put parentheses here, because if that's a minus sign in front, then that's very important that there are parentheses. So 2x plus x minus 4 equals 5. 3x minus 4 equals 5. Add 4 to both sides. 3x equals 9. Divide by 3 on both sides. X equals 3. So the x value of my solution is 3. So again, I want to plug in 3 for x into one of my original equations. Now if I plug it into this second equation, I already have a y isolated. So x equals 3, that's 3 minus 4. 3 minus 4 is negative 1. So the y value is negative 1. Now I want to show you that it would be the same if I plugged it into the first equation. It just would require a few more steps. I plugged in the 3 for x right here, and I'm going to solve for y. 6 plus y equals 5, minus 6, y equals negative 1. You see, we get the same value no matter which equation we plug it into, because again, that's what a solution is. It fits for both equations. The last two are some special cases. So again, I already have this equation solved for y. So I'm going to substitute this right here for this y. 2x plus, parentheses, negative 2x plus 5 equals 1. Okay, remember in substitutions, like in sports, you don't sub in somebody and leave the person in the game already in the game. Somebody has to come out in order for somebody to go in. So the y came out and the negative 2x plus 5 went in. Now again, because this is a positive right here, and this is an invisible 1, I don't actually need the parentheses. So 2x minus 2x plus 5 equals 1. 2x minus 2x is 0x, which is just 0. So really, I'm left with 5 equals 1, and we know this from previous studies that this means there is no solution. What does it mean when there is a system and the answer is no solution? It means the lines are parallel and they have the same slope, which means they will never intersect. That's what no solution means for a system of equations. Our last example is a little bit more complicated because neither of these equations have a variable all by itself. And in order to substitute, we must have a variable isolated, either x or y. So I can solve either of these equations for x or y. I'm going to solve this equation for y. That's just kind of what I'm choosing. It seems like perhaps it might be the easiest. So in order to solve for y, I'm going to add 4x to both sides. So 2y equals 2 plus 4x. Divide by 2 on both sides. Y equals 1 plus 2x. Take a moment, make sure you understand where I got that from. Now, because I have the y isolated, I can substitute this right here. Okay, substituting that y is going to come out. The 1 plus 2x is going to go in. So now I have 6x minus 3, parentheses. Again, the 3 doesn't come out, just the y. 1 plus 2x equals negative 3. 6x minus 3 minus 6x equals negative 3. 6x minus 6x is 0x, which is 0, nothing. So I'm left with negative 3 equals negative 3, which again we should know is all real numbers, meaning the solution is anything, which means for a system we call that infinitely many solutions, and that is because the lines are actually the same exact line. So if I were to graph those two lines on the coordinate plane, you would see that they're actually the same exact line. And in the same way, if you were to solve this equation for y, you would see that you also got 1 plus 2x. You would get the exact same thing. So notice that from the problem, you can't necessarily tell at first glance that they're the same equation, but once you break it down, you can figure that out. So again, make sure you understand that there's one solution or no solutions or infinitely many solutions for a system of equations, and now you know how to solve by substituting.
I've been waiting way too long. Yeah.